What's up, guys? Welcome to my channel, KB19 Fundamentals by Chakravarti. So, in this physics NEET, we shall be covering the rotational motion. Today, a short video, we shall be discussing angular displacement, rotational motion basics, linear motion, angular velocity, and question and answers. So, let us start. Angular displacement. So, let us write what is angular displacement. We shall be doing discussing the topics while solving some important questions. So, what is angular displacement? Here, when a particle moves in a curved path, the angle subtended by its position vector about a fixed point is known as angular displacement. So let us see how we can define. Suppose this is a path. Suppose this is a path, and we just keep 2 points P and Q. These are 2 points. Let us join them from another point O. This is one section. This is one line joining. This is another line joining. So these are 2 vectors demarcating P and Q point. So let us see here. So this is a resultant vector which can be said as delta S. So delta S, and let us take this vector, position vectors R1 vector and R2 vector. The angle sustained by these 2 vectors is, let us call this as delta theta. So when a particle, so what is an angular displacement? When a particle moves in a curved path, particle is moving in a curved path, the angle subtended by the position vector about a fixed point is known as angular displacement. Here, let us call this the unit. This is point A. Let us see, this is B. So unit is radian. Dimension. So if I do the dimension balance, M0, L0 and T0, it is a vector quantity whose direction is given by right hand screw rule. Direction is given by right hand screw rule. So angular displacement is a vector quantity. It is given by, its direction is given by right hand screw rule. So if theta be the angular displacement, theta be the angular displacement for particle moving in a circular path, the circular path of radius r, and S be the length of the arc, and S is here my length of the arc. S is equal to r theta. So we can say, suppose this is a circle, this is the radius r, this is angle theta, and this is S. Now we know that 360 degree is equal to 2 pi radian. So radian, this is the symbol of radian. You can also write it. This is the symbol of degree and this is the symbol of radian. So 360 degrees is equal to 2 pi radian. So in this way, I can represent that length of the arc is equal to radius into the angle sustained by between these 2 position vectors theta. So 360 degree, 2 pi radian. Now let us start with the angular velocity. So here what is the angular displacement? When a particle is moving in a curved path, the angle subtended by the position vector about a fixed point is my angular displacement. So delta theta is my angle here, the angle subtended by the position vector. So this is my angular displacement. So it has units of radian. Now let us start with angular velocity. Angular velocity. So this is angular velocity. How we know about angular velocity? Let us write this equation. So if we say omega, let omega be the angular velocity. Omega is equal to delta theta by delta t. Delta theta by delta t, where the angular displacement per unit time. So here, how we can write this delta theta by delta t? So if we want to discuss about instantaneous, let us write about instantaneous angular velocity. First, discuss instantaneous angular velocity. So what we can write here, that if omega, let us let if omega is my instantaneous angular velocity, I can write it omega is equal to limit delta t tends to 0, delta theta by delta t, which is my d theta by dt, which is the instantaneous angular velocity, nothing but my instantaneous angular velocity. So if I say about angular velocity now, it can be said as the angular displacement per unit time is defined as angular velocity. Now if a particle is moving from P to Q in time, let us say if a particle is moving from P to Q in delta t, where delta theta is the angular displacement during the delta time t. Suppose there is a particle, there is point P, there is point Q. A particle is moving from P to Q. Delta theta is the angle sustained between these two particles. So I can say in the time delta t, the particle moves in time delta t. I can say that omega here, instantaneous angular velocity, will be equal to d theta by dt. Now let us see some properties, or we can discuss much more discussions about angular velocity. Let us try about average angular velocity. How we can write average angular velocity? This is the superscript, or in the topmost portion we write a dash line. So this represents that this is the average. So average angular velocity is theta 2 minus theta 1, the angle subtended finally and initially by the time taken t2 minus t1. That can be represented by delta theta. And just let me write this delta theta by delta t, which is average angular velocity. This is average angular velocity. Now, what is its unit? Unit is what is its unit? Let us write its unit as radians per second. Radians per second. Now let us write about its dimension. Dimension I can write m0, no mass, no length dimension, but inverse time dimension, because per second is there, which is same as that of frequency. So if we say this dimension, you can say this is same as that as a frequency. So this angular velocity is also a vector quantity. Okay, so this is also a vector quantity whose direction is normal to the rotational plane, and its direction is given by right hand screw rule. This is a vector quantity. So this is frequency. So it is a vector quantity. This is a vector quantity. So whose direction is given by is basically is normal to the rotational plane. and its direction is given by the right hand screw rule. Right hand screw rule. Let us write let us write an expression here. V vector is equal to omega vector cross r vector, or we can write V equal to r omega when the angle between them is your yeah. So this angle is basically between them is perpendicular. When it is perpendicular or cross product, the sine 90 degree gives you 1. So we can write V is equal to r omega. Here, what does it mean? Let us take some space here. Yeah. So basically, omega here is your angular velocity. V is the linear velocity. R be the radius of the path. R is the radius of the path. And we have the following relation, which is V is equal to omega cross R. Let us see if the frequency, now frequency relationship is given by, if F is the frequency, we can write omega is equal to 2 pi F. And what about time period? Time period T can be written as 2 pi by omega. Okay. So the angular velocity of a rotating rigid body can be either positive or negative depending on whether the body is rotating in the direction of increasing theta anti-clockwise or decreasing theta clockwise. The magnitude of an angular velocity is called the angular speed, and which is also represented by omega. Let us write about differentiate linear motion and rotational motion. So let us write about some more examples here. So here, let me differentiate linear motion and rotational motion. So this is a rotational motion. Let us discuss some points. Now in linear motion, if acceleration is 0, V is constant, we can write S is equal to Vt. Okay. Linear motion, if acceleration is 0, there is no acceleration at all, that means that my velocity is constant velocity without any acceleration, and S can be written as Vt. What about rotational motion? If acceleration A is 0, or no, here we do not represent it by A. Let us rub this. If acceleration is 0, then we can write omega is equal to constant, and I can write that theta is equal to omega t. Okay, so basically here the angular displacement happens and the theta is the angle subtended between the two position vectors, and it is represented by V is replaced by the omega and t is my time. Let us see another point of difference between these two. Let us see one more instances. And then if acceleration is constant, another case is acceleration is constant. In case of linear motion, what happens? So first of all, we can write here that my distance covered. So distance covered is speed into time. I know that what is my speed is multiplied by time. That is the distance covered. I can write it as S is equal to U plus V initial velocity plus final velocity divided by 2 into t. Now, what about in case of rotational motion? Let us write rotational motion is also having acceleration as constant. So it is having acceleration constant. Then I can write that theta is equal to omega 1 plus omega 2, the average initial plus final, that's angular velocity, the angular displacement, the angle subtended, and the angular displacement is equal to initial angular velocity plus final angular velocity divided by 2 into t. So this can be written similarly. The second point here, that a acceleration can be written as v minus u divided by t. That is final velocity minus initial velocity divided by t. What about in the case of rotational motion? I can write it as alpha, which is equal to the angular acceleration is the final angular velocity minus the initial angular velocity divided by t. Similarly, the next point, let us see. Let us more focus about in the linear motion. Let us focus about the equation of motion. So we can write v is equal to u plus at. I can know the first equation of motion. So we can write that the final velocity is equal to initial velocity plus acceleration into time. So in the terms of my rotational motion, I can write that omega 2, the final angular velocity is equal to initial angular velocity omega 1 plus alpha into t. Point number 4, here I am writing the second equation of motion, which is more famous, known as S is equal to ut plus half of at square, Newton's equation of motion. So I can see here I have written the second Newton's equation of motion in case of the rotational motion. Yeah, the rotational motion I can write the same thing as here angular displacement theta is equal to omega 1 t plus half of alpha t square. So you see the resemblance, the resemblance here. I can write in this manner. Now Newton's equation of third equation of motion, here I can write that v square minus u square equal to 2as, final velocity square minus initial velocity square is equal to 2 into acceleration into the distance covered. In case of rotational motion, I can write the same thing as the final velocity is my omega 2 square minus the omega 1 square is equal to 2 alpha theta. Now the distance at nth time, so s nth is equal to u plus half a into 2n minus 1, and let us see here 6 is equal to theta nth is equal to so nth is the so at nth time I can write this equation s nth is equal to u plus half a 2n minus 1, and this now in the case of rotational motion I can write omega 1 plus 2n minus 1 alpha by 2. Now if I see here, C point, if acceleration is not constant, and is let us see, and not constant, the above equation will not be applicable. So these equations, the above equations are applicable when the acceleration is constant. When the acceleration is not constant, this will not be applicable. So for that case, we have the following expressions of the equation. So what we can write? First we can write v is equal to dx by dt. This is the final velocity and the distance, change of distance with respect to time. The second problem equation, we can write a is equal to dv by dt. Instantaneously it is changing, that is by dv by dt, or you can write that d square, second derivative of distance with respect to second derivative of time. Similarly, I can write the third point, v dv is equal to ads. Okay, so this is by the separation of variables. So dv by ds and divide a by v. You take the ratio of a by v, so you will get dv by ds. So here similarly I can write it as omega is equal to d theta by dt. Secondly, I can write it alpha is equal to d omega by dt, or it can be written as d square theta by dt square v dv, and in the third point we can write that this is omega d omega is equal to alpha d theta, v dv equal to ads. Similarly I can write in rotational motion omega d omega equal to alpha d theta. Now let us solve some problem. So here let us take one example here. Example number 1. What it says, a wheel of mass 6 kg is rotating at 300 rpm, its angular velocity. Find its angular velocity. You have to find a wheel of mass 6 kg rotating at 300 rpm, and you have to find its angular velocity. So you can find it. How you will find it? So you can write omega equal to 2 pi n by t. Same formula we actually derived earlier. We actually got earlier. We represented. So you can write it as omega is equal to 2 pi n by t or 2 pi f. Okay. So here, what will be my omega here? It will be actually 2 into 3.14 into 300 rpm divided by 60. So I'm converting into seconds. Time is my 60 seconds. 60 seconds. I'm converting into seconds. Let us multiply by use of calculator. What I will get is 31.4 radians per second. Now let us see example number 2. So what does example 2 tell us about? It's asking. So example 2 is asking if angular velocity if angular displacement, let me more precise, angular displacement of a particle moving on a curved path if angular displacement of a particle moving on a curved path be given as equation is there, theta is equal to 1.5 t plus 2 t square, where t is in second, the angular velocity at t equal to 2 seconds. So it is asked the angular velocity at t equal to 2 seconds will be how much in radians per second? What it will be? So that will be basically I have to write out. Let us write the solution. Theta is equal to 1.5 t plus 2 t square. Let us do d theta by dt. 1.5 plus 4 t. Now d theta by dt at how much? What's the time? 2 seconds will be at t equal to 2. This is basically t equal to 2 will be 1.5 plus 4 into 2 equal to 9.5 rad per second.